Greetings, I'm Dick Krafft, and I'm one of the people in town that was involved with the reconstruction of this historic Nickless-Hubinger Mill. And it's historic and important to Frankenmuth history because it represents one of the earliest industries along the Cass River in Frankenmuth. The original mill burnt down at this site, and it was rebuilt and remained an operating flour mill until 1956. After that time, it was torn down and the site was empty for some years until local folks decided to reconstruct it and have it as a historic landmark. So it's an operating mill. It has the ability to produce flour, and we'd now like to take you through the mill and show you how the mill actually operates. We're here at the Nickless-Hubinger flour mill in Frankenmuth, Michigan. This mill is a restoration of a mill that was torn down here in 1956. The original location housed the mill in the middle 1800s, but that mill burned down in about 1908, and in 1910 a new mill was built, which was here till 1956. So this was an effort to capture the history of milling in Frankenmuth. Right here we're standing in the location of where the process actually starts. The clean wheat is brought here and it's dumped in this hopper that's in front of me. That is a very important part of the milling process, the cleaning of the wheat. The wheat has to be scrubbed externally. It has to be subjected to vacuum and air to get all the dust and stuff off so that only clean wheat enters the milling process. After the wheat has been cleaned, it gets elevated to the top of the mill, up to the fourth floor, and it comes on down to the system. The first actual processing of the wheat takes place here in what we call the first break roll stand. What we have is we have the wheat coming through a scale, and it drops down into here, and there's some rolls inside that run towards each other. And these rolls have a corrugated surface on them, with one roll running faster than the other. The objective being we want to tear the wheat kernels apart. We don't want to grind the outside of the wheat berry into the flour. So that's what we do here. After it goes through that first break roll, drops down here, and we can take a sample of it and feel it. And from here it goes on up to the third floor where it goes through the sifter and where the flour separation process commences. So each side of this roll stand does a different job. The other side of this stand has got different corrugations of rolls, and it works with a different product that we'll talk about a little bit later. We have, in this mill, 4 of these roll stands, which means we've got 8 different processes because we do 2 processes in each stand. You'll notice these are all wooden spouts in an old mill. This is known as a mechanical mill, which is how we used to do things years ago. But nowadays we use pneumatic spouting and so on. But note the workmanship in here, these diamond spouts and so on. It took some real skilled millwrights to make these spouts. We're now following the process through the mill, and we have just left the first break roll stand where the wheat is ground for the first time. It is elevated from that level up to the top of the mill, and we bring it down here to the sifter. Now the sifter is a very integral part of the milling process because here's where we do all the separations of the flours and the bran and the midge. What we have here is, if you'll notice on the other side, we have 8 different products coming into this sifter on the other side of this sifter. There are 8 sections in here, and the product that we introduce over there is ground wheat, and that's flour, bran, and midge all mixed together. So our job here is to bring it across here on silks and separate those. The far end of this sifter has got the finest silks in it so that the flour can go through those silks. And as we come towards this end, the silks are coarser, so the most coarse material can go through. If you'll notice, we come in with 1 product in each section, And we exit here with anywhere from 3 to 5 products on this end of the sifter. One of those products is finished flour. The other 2 or 3 products, whatever the case might be, is coarse material that goes on for further processing. And we repeat this process until we've got all the flour removed from the wheat kernel, which is about 45 pounds of flour for every 60 pounds of wheat, 75% extraction. So this sifter is very important for the milling process. And this is called a plan sifter, which is a sort of sifters that were used into the early 1900s, but have not been really in commercial use for at least 50 years because we now have a different type of sifter than we used to have in those days. So this sifting takes place obviously all the time that the mill runs, and this sifter, by the way, is not connected to the floor. It's totally suspended from overhead so that it can have this free movement. In the milling process, it's an ongoing challenge to keep separating the flour from the bran and from the midds, bearing in mind that the main object here is to add as much flour as we can. One of the machines we use to make this happen is this purifier machine. That's what that's called. And what we do here, we introduce the raw material or the ground product on this end of the machine, and we have vibrating sifters that move the product towards this end. Again, we have fine silks on the beginning side of this machine, and as we get towards the tail end, we get coarser screens in there. So we make a number of separations here, and one of these separations is finished flour. So this is called a purifier. Now then, another machine that we use in the process of milling flour is a machine called a reel. This is another machine that helps us make these many separations we have to make in the milling process. In this mill, we probably have 20 different products in motion at any given time, all the time. And now in this reel, the way this works is, this is a tumbling reel in here. That's why the machine is called a reel. And it's got a cover of silk on it. And the flour is introduced, or the product is introduced on this end, and it works its way towards the other end. And as it's tumbling here, we hope for the flour to fall through the silk, and then that becomes finished flour. And the product that discharges above the silk, it doesn't go through the silk, goes on to the next roll stand for further processing. In the process of restoring this mill, I might mention at this point of our tour, we had the help of many, many very talented craftsmen to help us restore the machinery back to displayable condition and usable condition. And here's a good example of the work we had to do to get it from how we found these old machines to their present state. Here you're seeing a machine that we haven't done much work on. And here you see a machine that was in much worse condition than that, but it's really a lot of craftsmanship in here. And I need to mention the most skilled craftsman we had here was a man by the name of Winnie Kern. He worked in here for several years restoring all of this. This machine is called a bran duster. And here again, the bran, which is the outer layer of the wheat kernel, has flour clinging to it. Our job is to remove the flour from the bran because that's really what we're after. And this machine helps us do that. The product enters the machine here, and there's a reel in here that turns with a screen on it. And here again, we want to we want to be abrasive to the bran so the flour falls off through the screens. So this is called a bran duster, and it helps that process. I just point out this little piece of wood here that Mr. Kern made to fit this machine, and so that it would look like the original machine. And I think it's an excellent example of the good work that Mr. Kern has done for us here. So this is another machine that helps us get all the flour out of the wheat kernel. This is the flour bin. This is where the end product ends up just before it goes into the packer. And the packer we'll see a little bit later because it's on the main floor just directly underneath here. So this is where the end product gets stored before we pack it. When you're in the flour milling business, one of your enemies is dust, because when you really think about it, flour is dust because it all has to go through a silk as fine as a hose, a stocking. So dust is always a problem, and so we have to spend a lot of time and effort to have suction on every machine in the building to try and pick up all the dust that we can so it doesn't end up on the outside of the machines or on the floor. And as we pick up that dust, we have to do something with it. So what we do is we blow that dust into what's called a star filter. And that's what we're looking at here. The process is the flour gets blown, the dust gets blown in here, and then the dust settles down by gravity into these socks. These are fabric stockings. And then these keep turning, as you see, and at the very top, there's some hammers. You can hear the sound of them right now, and they pound on here like this, and to loosen up the dust that was accumulated here, we drop that down into the center, into a screw conveyor. We bring the dust back in to the milling system, and it ends up as feed. So this is the old star filter, which we don't use anymore because they're too dusty, but that's how it was done for many years. In the milling process, a lot of elevation has to take place because, as you've noticed by now perhaps, we grind this wheat and it becomes many different pieces before its finally end product. We would have, as I mentioned earlier, probably 20 different products flowing through here at any given time. Here in front of me are what we call elevator legs. We have 9 of them here. And what these elevator legs do is they pick up the product that's gone into the basement from the various machines, gone in there by gravity. Then we lift these products up to the top floor and direct them back to the sifters that we saw earlier here. And while this machine is, the leg is not running right now so we can show this better, what we have here is a belt. And attached to this belt are these cups. And this belt runs this way, picks up the product in the basement with these cups, carries it up to the top floor and into the sifters. So in a flour mill, high ceilings are very important because we rely so much on gravity to go from one process to the next process, and then we end up here again in this elevator system and we elevate the product back upstairs. In the days when this machinery was making flour, all of the flour that left the building left in a bag. Today that's no longer the case. Probably 80% of flour is shipped in bulk. But back in the days of this, when this machinery was making flour, everything was packed. We're looking here at an old flour packer, and this packer can pack 25-pound bags, 50-pound bags, and 100-pound bags. What the operator did, he took a bag and pulled it up here like that, and he'd push the clutch, and it would grind the flour down into the bag. But there was no weighing device in there at those days, so the operator would have to take the bag off this platform after it's gone down, set it on this scale, and weigh it. And if it was a half a pound short or a pound short, he had a bucket here, and he'd scoop some flour and put it in the bag. Or if there wasn't too much in there, he would take a little bit out and put it in his barrel. So that's how the flour was packed. The bran and the mids, those are the byproducts of a flour mill. They are packed with a machine that's very similar to this. And just for reference, out of a 60-pound bushel of wheat, 75% of it is flour, and the other 25% is half bran and half mids. Both are used for production of animal feed, or in the case of bran, nowadays all of our bran we produce is used in cereal bran production. So this is where it ends up. We have just seen a flour manufacturing setup that is very similar in process to what we do today. However, milling today uses bigger machines, but the basic process of grinding and reducing and sifting is still the same. Prior to the invention of the roller mill, which we just saw, all of your wheat and corn was ground with stones. And this is what we have here. We have a stone where the wheat is introduced here. It's dropped into the center of this stone grinder. And there's another stone that's stationary on the bottom. And the top stone turns. And there's corrugated surfaces on these stones so that we can reduce the wheat or the corn, whatever it might be, to a smaller particle size. And then it works its way out to the end of to the side of the stone and gets collected for processing. In this mill, this particular machine is driven by a water wheel outside the building. And so this takes about 10 horsepower to run this stone. I should point out another feature that Mr. Kern, whom I mentioned earlier, designed and built. And that is this derrick-like device, which is used to lift up the stone for either cleaning or for sharpening of the stone. And you'll notice here the claws that he designed, which can be used to pick up this stone. But I think it's another example of Mr. Kern's very inventive mind to build this here for servicing the stone. Now these stones are no longer used in commercial production of flour to any extent. It's interesting to note, I think, that there's only a few places on this globe where the stone is available to be mined that has the consistency and the strength and the ability to withstand the abrasive grinding action. There's very few places, and most of these stones came from the Atlantic Ocean off the coast of France. I'm not sure if this one came from there, but that's where a lot of them came from. We're now in the basement of the mill, and we're looking here at the line shafting. We have one big motor down here that does a lot of the driving of the machinery, and we do that through line shafting as opposed to having separate motors on each machine. It's much more power efficient to have just one motor than many motors. So what you see here is a line shaft with a series of pulleys, and we drive the roll stands on the main floor from this line shaft. All of them get driven from this one shaft, as well as the packer and a few other small machines. So this is where we produce the energy and transfer it into the machines. Up in here now, we mentioned earlier that we drive our stone with a water wheel. And up in here is the shaft that comes in from the water wheel out by the river, and it comes in here through this set of gears and drives the stone that we saw on the main floor. After the product leaves the stone on the main floor, it comes over here onto this sifter, and we sift the coarse material out, and we save the fine material that we set out to produce. Also, while we're here, back in those days, most of your pulleys were wood pulleys. This is an old craft that is not practiced anymore, but they were very, very good, and they lasted for many, many years. And just another example of some of the equipment that was used back in the late 1800s and early 1900s. Wooden pulley. There are many interesting examples in this mill of how technology has changed over the years from how they were back in the 1800s, early 1900s. And here's a good example of it. Back in those days, we didn't have roller bearings and ball bearings, and so we had Babbitt bearings. And what we see here is truly Babbitt bearings. And what we have is the shafts are actually turning not on bearings, but rubbing right on the Babbitt. The Babbitt is a combination of lead and something else, but it's important that we keep oil in here so that the bearings are always oiled. But that's an interesting change. One of the things we learned is that you pick up around 10% power efficiency going from Babbitt bearings to roller bearings.
Now, can you explain how they make the Babbitt bearings about pouring the...
It's an interesting craft. There's only several people that I still know how to pour Babbitt bearings. But if this bearing wears out, which it finally will, you take this top off here, the bottom half stays in place. You can see the seam here. Then you have to form the top, and you heat up this Babbitt so that it becomes a semi-liquid. And you pour it in the top here into these holes, and then that forms the bearing. And then after it cools off, you can slip the shaft back in, and you're back in business.